Okay, welcome back. Here we're going to look at sampling distribution. So basically what this means is, for a few of the other exercises that we've been working with, we've looked at a normally distributed random variable, has some mean mu, and then we're looking at individual observations that lie within that distribution. So in the population that we're looking at here, I have a population with a mean of 300. So there's my mean 300. I have a standard deviation of 40. And so that gives me the distribution of individual observations within that population. But if I'm going to be taking samples from that population, samples of size n, well, we might want to be interested in what's the distribution of sample means from that population. So in order to do that, we'll just go through some of these preliminary exercises, and we can see what we can do with that information. So what is the expected value of the sample mean? Well, the expected value of x bar is always going to be mu, the population mean, which in this case is 300. So that one's straightforward. I take a sample. My best guess of that sample mean is going to be whatever is the population mean. So expected value is always mu. What is the standard deviation of x bar? So what is the standard deviation, or what is the spread? What is the distribution of possible sample means? So for this one, our notation is sigma x bar, so it's the standard deviation of sample means, and this is equal to the standard deviation of the population divided by the square root of the sample size. So you can see that this changes for different sample sizes. So if we just plug in our numbers here, standard deviation of 40 divided by the square root of 125, where's my calculator here? 40 divided by square root of 125 equals, so 358. So there we go. There's sigma x bar is 3.58. Okay, and so of course we can see that as that sample size is going to get larger and larger and larger, as that sample size gets larger and as it begins to approach whatever is the size of the population, then this standard deviation of sample means is going to get smaller and smaller and smaller, meaning that my sample size gets larger, I'm going to be getting closer and closer and closer, more consistently close to the population mean. So that's something to keep in mind, and that's something that we'll come back to a little bit later. So a larger sample size, I'll have more accurate estimates of that sample mean when I take larger samples. Describe the sampling distribution of x bar. So distribution of x bar, I'm going to come down here. It's normally distributed, normal with an expected value of 300 and a standard error or standard deviation of x bar equal to 3.58. So that just gives me the parameters of the sampling distribution of x bar. What does a sampling distribution show? Well, I've kind of been talking about that as we've solved these other problems. It shows me the distribution of sample means of varying sample sizes. So as that sample size gets larger and larger and larger, the distribution of sample means gets increasingly narrow, or my point estimates, my sample means will become increasingly accurate as far as estimates of the true unknown population mean. So what we're going to be using that for is actually calculating probabilities that a given sample mean is within some range, some distance of the true population mean. So that's what we're going to get to later on, using those point estimates of x bar, or sorry, using x bar as a point estimate of mu, this unknown value, and calculating probabilities of how close are we to that true value. So that's where we're going to go. To get there, we need these basic starting points. So I hope this helps. I hope this makes sense, and hopefully you'll continue watching these videos as we progress. Thanks for watching. Bye-bye.